Well, as you can see, Ted's been helping me with design for a bit of electronics that I'm going to put on the bike. I think I said already I wanted to make the ignition total loss. I haven't got an alternator on the bike, and I was going to find a place to put a battery, regular sort of, you know, lead acid battery, or this one's a lithium one. And then I suddenly realised I could use one of these Makita plug-in things, and I think the 5 amp hour one of these will give me about 3 hours running, which is plenty. I don't need anything like that, and then I can just click another one on and then carry on if I had one in my pocket, if I needed to keep running that long. But so the design we came up with was for some kind of mount for the battery, but for using it, of course, something to protect the low voltage, because if you run the voltage down on one of these batteries too much, it basically destroys it. And I'm not 100% sure whether it has a circuit inside it or not. I think it doesn't, but the internet is not 100% clear on it, and I'm not going to take the battery about to find out. I know there's clever stuff inside for charging, but I don't care about that. I'm talking about preventing it from discharging too much. So I am going to put a low voltage cutoff to not allow it to go below about just above 15 volts, I think, is the value. If it goes below that, then you just turn off and stop draining any more power from it. Then, because this is an 18 volt battery, I only need 12. I've got a 12 volt coil, so I need 12 volts for that. I'm going to use this thing called a buck converter, which that has arrived today. So the first piece, well, I've got 2 pieces of the puzzle now. I've got the battery, I've got the buck converter, I've got the handlebar switch. I'm waiting for a fuse holder, I'm waiting for a battery holder, I've got the coil, I'm waiting for the low voltage cutoff and a box to put it all in. But I thought I'd made a mistake with this, because this is a 24 volt to 12 volt converter, and I looked at the specification and it says it stops working at about 17 volts or something like that. It's like 50 to 17 volts where it will give 12 volts out. So I got a bit worried, but anyway, it's arrived and I've tested it and it seems to work pretty good, and I'll just show you. So I've got my, hopefully you can see this, I'm kind of edge on the bench, and that shows up okay. I'm going to put some volts in the front, in the input side, and I'll measure the volts on the output side. You can read the meter, yep, so this is all working good. So I think this one's the plus. And that's a good start. Nothing interesting. Let's give it a bit more voltage. Oh, there we go. So yeah, I'm getting just over 12 volts out of it with 15 volts going in. I can take this voltage up to like, oh there we go, 25 volts in and just under 12 volts out. And I can drop this down, drop it down, 17 volts, 16 volts. So 15 volts, it's still giving out 12 and a quarter volts, that's fine. The interesting thing is, I wonder if it will start at that voltage. So 14.7, let's just stop it. And start it again, because maybe it won't start at a low voltage, maybe that's the... Oh no, that's okay. So yeah, 14.7 volts. I'm not going to let it go down that low, and it's still giving out 12 and a quarter volts, which is good, and it's rated for 5 amps maximum. The coil was drawing 2.2 amps with the coil with the points closed, and I worked out there's about 270 degrees of the crank rotation is when the points are closed, and then the other 80 odd degrees is when the points are open. and that were anyway, if you do the maths and divide it by the 270 over 360 times the 2.2 amps, and it ends up about average of 1.5 amps, I think, is what the current is going to be drawn from this. Well, slightly less actually, because it's a higher voltage. These are supposedly about 90% efficient. Anyway, I reckon a 5 amp hour one of these will run for a couple of hours or something like that. And since I only need it for a few minutes, for hill climbing anyway, but I'm going to ride around the road on it, so I don't know, half an hour is fine. So yeah, forgot to bring Ted into the conversation as usual. Ted helped me to do the design for this. It's not really a lot of a design for it, and yeah, I'm quite looking forward to see if it works. I've got to mount a plate on the side of the bike to mount it all on, but yeah, depending which piece of these comes up next in the post, that'll be the next little part of this video. Apologies for not having a video earlier than this, but yeah, there's been a lot on, and it's getting there. All the parts have arrived now to finish off this project, I think, with a bit of luck. I've got, packed up in here, I've got a big sheet of aluminium to make the back plate. I've got a plastic box to put everything in. I've got a fuse holder, so it's all nice and safe. I've got a spare voltage converter. I'm not sure if I talked about this before, but I've got a spare one, slightly different. I might use this one in the end, I'm not sure. The other voltage converter that we talked about earlier, I've put a light bulb on that for a load in place of the coil. It's about the same kind of current as the coil. We'll check in a minute. And this is the low voltage shut-off device that I'm powering from the power supply at the minute. So power supply, haven't got a fuse or a handlebar switch, into the voltage cut-off, into the voltage converter, to the load. This has arrived, which is the connector / mounting for the battery. So this will go on the bike, and then it's just a matter of just putting that on, and then I've got power, and then I want to change it, put another one on. I think that's going to work really well. It doesn't have, I'll have to figure out how to mount it, but I'm sure I can drill through or something. But yeah, quite pleased with that. So those are all the bits. So I'm going to try to test out this low voltage cutoff, because I've not used one of these before. In fact, I've not used one of these before either, so it's all a bit new to me. So yeah, wired up to the power supply. I'm going to turn it on. And we have power, and it's currently 17 volts, 18, or I'll make it 18 volts, and it's drawing about an amp at that voltage. Actually, if I turn it down to, oh, there we go. I see it works. So as I turn the voltage down, eventually, at some point, that's 15.5 or 15.4, 15.3, somewhere between 15, around 15.4, 15.6. Yeah, around that voltage, it turns off. What I've noticed though is that it clicks when it turns off. So it seems like it's continually retrying, and I think that's because it's somehow testing the battery voltage to see if it's gone back up again. I think that's what it is. I'm not sure. So that's a little bit weird, but there's no power going to the light bulb at all. So the bike would have stopped by now because it wouldn't have any power, and so I would have disconnected the battery and it won't be damaged. And that's the main thing, that I don't leave it switched on with the coil drawing power and yeah, just ruining, because as I said, if you leave one of these batteries on for too long, if the voltage goes too low, you can't ever charge them up again, and they're dead basically. So, and can't remember the price, but they're not cheap, these things. So yeah, I'm pleased with that. I've got all the parts. Say I need to cut out the plate on for a relevant place to put it on the bike, mount these components, and should all be good to go then. yeah, that's it really. So yes, low voltage cutoff protectant. It's quite clever, but I don't know why it's doing that. That is a bit weird. It does the job, but it's a bit weird. And this thing certainly seems to be very efficient. So yeah, I'm pleased with that. Need to get on and actually file some metal and screw some things and join some wires and fit fuses and things. Okay, I'm just doing a little bit of cardboard aided design here to mount the battery and the control electronics on the bike. This seems to be a nice space for it. It's a very tight fit. I'm just going to cut a little aluminium plate out, mount it on the mudguard bolt at the back and the battery bolt at the front. I think just 2 bolts should be enough. Hopefully the vibrations won't kill it. Although, yeah, it's BSA, so who can tell? So it's going to be something like that. I need to come around here. Follow that line like that somehow. And then don't really need any of that, so that go here. Curve. I don't know, something like that. And then don't need this bit either, so that can be a curve. Maybe straight up. Something like that. Curve, curve, curve. Curve like that. Like that. And around here. Something like that. I think that will look alright. Yeah, so anyway, bit of fiddling with that. Cut it out. And mount it up. Well, I've never actually tried cutting aluminium with a bandsaw, but I retrieved my trusty one here from its slightly damp storage location, so it's a bit unloved, but so I'm just going to draw around this. CAD at its best. And then we'll proceed and try and cut it out. I need to get it right first time because I've only got one sheet of aluminium. But what could go wrong? Okay. So yeah, I'm told it's straightforward. Bit of WD-40 for lubrication. Should give it a good. Say it's not been used in some while. Is it going to go bang? No. Just check the sound. That's too loud. That's better. There he goes. like a nice roux butter. That cuts so easily. Oops, try not to get in your way. Almost no pressure to cut that. Amazing. Oh, I hope that wasn't too noisy. We'll find out in a bit. Yeah, bandsaw. Bandsaw, where have you been all my life? Let's see how that fits. Okay, it's a little bit. I need to take a bit off here. How's that looking? It's still too small from here. Fix the sound afterwards. What do you think? I think it's almost pro looking. That there. put that right next to it. Yeah, I'm happy with that. So I need to just clean up the sharp edges, drill the 2 holes, and then mount the pieces, do the wiring, done. Amateur metal worker, here we go. I'm having made it now, I'm not 100% sure it's going to withstand the vibes, but we can give it a go. And that is a million miles away. Why is that? What? Measure. Oh, damn it. I don't believe that. I didn't measure it twice. Ugh. Oh, how annoying. How was that so far out? Yeah, major error there. That is strange. What did I do wrong there? Poop. Never mind, won't see it. But oh no, it's there. I need to drill this hole. Probably slot it now. I've made such a mess of that. I shall be back in a minute. Well, that was embarrassing. Anyway, you're not going to see it. It's perfect. Look, perfect. That hole, perfect. Years ago, when I was a lad, I used to work in a machine tool company, and there was a guy there that made the panels, that did the panels for the electrical parts, and he was known as half a hole Jack. You get one guess why, and that still doesn't line up. Good grief. So what it is actually is this, it's a very hot day today, and this sheet is at its largest size, and in the winter when it's really cold it's going to need a slot so that it can shrink and not buckle. So I've allowed for that in my calculations when I'm measuring it. That's my story, and I'm sticking to it for now. Okay, it fits where it touches, as they say. What do we think? How long do we think it's going to last? So, this I need to make sure I can get the battery in and out, just to prove I do think a little bit ahead, and some of these things I do. So if that was there, yeah, loads of room to get that in and out. And then this box, something like that. What do I do with the pen? There. Ugh. That's all I need to mark, isn't it? I can do the rest. I can line up everything else from that. I've received an upgraded low voltage power disconnector module thing. I saw this one was going to take a long time to arrive, so that's why I ordered this one. But this one is much better than the other one. This one, you remember, when it reaches the low voltage, it clicks on and off, which is, I'm sure it'll work, but it's just a little bit annoying. And bonus, this one's got a voltage display. So what I might try and do is see if I can cut a little window in here. In fact, there's a recess bit. I could cut a window in here, and I can have a battery voltage readout as well. So there's fancy. This one allows you to set both the low voltage and the high voltage limit. So when it's below the low voltage, it switches off, and then it won't switch back on again until it gets back to the high voltage limit. And I think it's I can't. What did I set it at? I set it at. This is the high voltage limit. So high voltage limit is 15.7. I sure had it. Get this right. Sorry, the high voltage limit is the lower button. That's confusing. So it will cut off at 15.7, and it will not reconnect again until 16.9. So let's see how that works. Currently we're on 15.7 volts, so it shouldn't turn on again until we get to 16.9. Sigma 5. There we go, 16.9, and it comes on. And then the off point, it should be 15.7, which actually I need to, why is it 15.7? I wanted 15.5. I'm going to go for 15.5 as the low voltage. So just wait for that to stop flashing. So current voltage 16.9. So it does take a little bit of time to react. It doesn't happen immediately, which confuses me. So dropping the voltage down 15 point, there's 15.7.8, 15.7. 15.5, 15.4. What did I set it at? Ah, there we go, yeah. So 15.4 volts. What did I say? I'll just check. 15.5 volts, actually, it will cut off. And yeah, it won't go back on again until it goes above. So obviously you have to put a freshly charged battery in order for it to turn back on again. And you don't get any of that annoying clickety stuff. So yeah, that's it, basically. I've got everything I need. My plate is ready. I've hidden my special temperature enabling design here because I'm going to file a patent on that rather. So you don't get to see the details of that. Sorry, but yeah, I just need some. The next video is going to be putting all this stuff in a box and putting the wires together, and yeah, so possibly putting a little cutout in the front so that I can see the voltmeter, because it seems a shame to hide such a fancy display, and it looks technical and people will go, wow, that guy really must know what he's doing. So yeah, I'll put that up there. This needs to go in. Where does the output need? I need the connector block, so I need to get that in somewhere. And a fuse basically, and that's it. So I need to get all those in there somehow. Fasten this onto the plate, connect the wires up to the rest of the bike, and yeah, it should be ready to go. So yeah, I need to make a little cutout. Make a little cutout in this box, and it will look high tech and go faster. What do you think? So yeah, I'm going to finish the video here. Have a cup of tea. I'm going to finish the video here because it's got a bit long already, and the next one will probably be just putting this together, putting the battery together, voltage readout, clipped on the bike, and the bike hopefully will be running and we'll all be happy. Ted. So yeah, as always, thanks for watching. Please like and subscribe and all that stuff. Many of you have liked and subscribed, so thank you for that. And yeah, we'll see you on the next side. Time, issue, volume, chapter, whatever. Thanks a lot. Bye bye.